Okay, so it's Mr. Bicen here, and in this video we're going to be doing every exam question that has ever been asked about cumulative frequency, and not the box plots because I've just done that in the previous section, but in this video we're just looking at cumulative frequency diagrams. Like I always say, if you do want to use this document, which is fully hyperlinked, it is linked in the description so that you can use it. Okay, so these are all going to be about cumulative frequency graphs, and it says the cumulative frequency curve showed some information about the heights in centimetres of 60 students. Work out an estimate for the number of these students with a height greater than 160. So first of all, I want to go to the graph and I want to read at 160. I want to read up to the graph, and then I'm going to read across here, which looks like it's going to be at 48, I think. So this tells us that up to 160, there are 48 students below. So from the graph, we can see that there are 48 with a height lower than 160. And so higher than 160 will be these students at the top. So we're going to do 60 minus that 48, which is 12. So the answer is that there are 12 with a height greater than 160 centimetres, excuse me. So just need to be really aware of the fact when you do cumulative frequency, these values are always telling you everything up to that value. Because we wanted these, it was corresponding to this section. So we've got that 12 there, perfect, and they've got a range of values that they would accept. So we've got a cumulative frequency graph about the weights of 60 potatoes, and it says, first of all, use your graph to find an estimate for the median. Well, because there are 60 potatoes, we're going to go to the middle one. We don't have to do any +1 or anything with this. We're just going to look straight across at 30, and then we're going to look down from 30, and it finishes at here. It looks like the value that is 57. So I'd say our estimate for the median weight, we came across at 30 and down, is going to be 57 kilograms. Jamil says that 80 minus 40 equals 40, so the range of the weight is 40 grams. Is Jamil correct? You must give a reason for your answer. Well, we don't know. Even though we've got 80 here and it's going down to 40, we don't know if the lowest weight is actually 40. So is Jamil correct? We're not sure. Let's say this. He may not be wrong. He may be incorrect, as we don't have the highest and lowest values, as we don't have the specific high and low values. Or weights, I might say. Okay, and then part C, it says show that less than 25% of the weight of, less than 25% of the potatoes have a weight greater than 65. So I'm going to go to 65 grams this time, and I'm going to look up from 65, and then I'm going to look across. So that is 49. So for this part, we've got 49. So being greater than 65, I would do 60 minus 49. Well, that is 11. And I'm going to just do that as a percentage. So I'll do 11 out of 60, times it by 100, separate part of calculation here. And we're going to show that that is less than 25%. So I'm going to do 11 out of 60, multiply it by 100, which is 18.3%, 18.3%, which is clearly less than 25%. So let's see if we've got these ones right. We've got the 57 kilograms, and Jamil may not be correct. So the maximum weight could be less than 80 or the minimum weight could be less than 40. That's the same thing as what we've said. And then I've done it in a slightly different way to theirs. They have done it reading, oh no, it's 48 and 49, that's fine. But you could have done it and just done a comparison. We've said that it's less than 25%. You could have found 25% of 60 and said 11 is less than that, but guaranteed this would also give the same mark as well. Okay, the grouped frequency table gives information about the times in minutes that 80 office workers take to get to work. Complete the cumulative frequency table. And then we're going to draw the cumulative frequency graph here, and then we're going to do some kind of estimate later on. So I'll zoom in for this part that we've got here. Now, to find the cumulative frequencies, you literally just keep adding on the previous frequency. So the first one is 5, then I'll do the 30 plus 5, which is 35. I'll then add on the 20 from the next layer, which takes me to 55. I'll add on the 15, and 55 plus 15, that is going to be 70. And then I'm going to add on the 8, which gives me 78, and I'll add on the 2, which gives me 80. Now I'm happy with that 80 because of the fact that there were 80 office workers. Now when you plot these on the grid, you're going to plot these ones in yellow with these ones here in yellow. It's not midpoints, it is just those upper values that we've got there. So I'm going to begin by doing the 20 with a 5, which will be here, and I'm going to do 35 going with 40. The 60 goes with a 55. The 80 goes with a 70. 100 goes with 78. And 120 goes with 80. Now, because we know that the group is starting at 0, we're going to begin it at 0 and we're going to connect these together. Now, some teachers might say these have to be connected together using a curve. Well, you can do them with a ruler, and actually I just prefer doing them with a ruler. I just think it's kind of easier to get all of the marks. You don't have to try to do like a smooth curve. They do accept either of these though, okay? So there is our cumulative frequency curve. It then says use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. So it's the same kind of stuff as before. We're going to go for 90 minutes. We're going to look straight up from 90 to here. And then we're going to look all the way across. I think, according to my reading, it looks like it's between 72 and 74. So I'm going to say that this is 73. So more than that is going to be 80 minus 73. That is going to be 7, and we want to find a percentage of the workers. So there are 7 workers out of 80. To make it become a percentage, I'm just going to times it by 100. So I'm going to do 7 out of 80, and I am going to multiply that by 100, and I have got 8.75% for my calculations, 8.75%. Okay, we'll double check that we've got that last part right, because I can guarantee these bits are all drawn right. But they've said it's just a follow through from the graph. So yeah, these are all the kinds of ones that they would be expecting here. I said 8.75, looks like they'd accept anything between these values that we've got. And do notice that they don't have to be drawn as a smooth curve. They could be done as line segments and you'd still get all of the marks. So there's a range of values that they would be accepting for this one. Okay, the cumulative frequency table shows the information in the time in minutes taken by 40 people to complete a puzzle. Draw the cumulative frequency graph. Okay, so we're definitely going to need to do the cumulative frequencies. Oh no, they've already done them for us. I've noticed they've just done them for us, so they just want us to do the drawing ourselves. So again, we're going to be doing these values with these values. So I'm going to get the calculator to the other side so I know where I've kept it. We're going to do 40 going with 5. I want to do this in blue. 40 goes with 5. 60 goes with 25. 80 goes with 35. 100 goes with 38. And 120 goes with 40. Now it's going to start, because it starts at 20, it's not going to go to the origin. It's actually going to start down here at 20 as the first point. So that first value goes with 0. And it says, use your graph to find an estimate for the interquartile range. Well, I guess I should probably finish the first part of the question, which is to connect these together. Like I said, you can do them with a ruler or you can do them with a curve, but I'm going to do them like this. Now for the interquartile range, we're going to want to find out the lower quartile and we're going to want to find out the upper quartile. Now, because there are 40 people, that's nice and easy for the quartiles. That would be the median, that would be the lower quartile, that would be the upper quartile. It's a quartile because 10 is a quarter of the way between 0 and 40. So I'm going to draw a cross at 10 for the lower quartile, and then I'll look down here. I would say that looks like it's about 45. If this is 50, I would say that that is 45 for the lower quartile. And then the upper quartile, let's do this in a different colour. That's going to be going across at 30. Remember, it's a quarter of the way along. And then when I come down here, that looks nice and easy. The upper quartile is just going to be equal to 70. So I didn't like the words doing that. Let's just quickly erase that. And so the upper quartile is going to be equal to 70, which means that the interquartile range, which is the upper quartile take away the lower quartile, is 70 take away 45, which is 25 for this. It then says for part C that one of the 40 people is chosen at random. Use your graph to find an estimate for the probability this person took between 50 minutes and 90 minutes to complete the puzzle. So I'm going to do between 50 and 90, which means now looking at this part along the bottom. So I'm going to go to 50, and that is going to correspond to 15 people. So I was looking up here and then across. I guess I should have said before this was the way I was looking for these ones. And then the other one that I'm going to do now is for, what did they say, 90 minutes. So I've done 50 minutes, I'm also going to do 90 minutes. Now when I draw at 90 minutes up here, I'm going to look across the graph, and that looks to me like it's a little bit, this is 30, 35, I'd say it's about 36 or 37. We'll go with 36 for this one. So the amount of people that took in between would simply be 36 minus 15, because 36 took below, 15 took below that. So 36 take away 15, I think this is a calculator paper, but it's going to be 21 for that bit. So the cumulative frequency graph, they want you to use it for these bits. We'll just double check we've got 25 and 21. So we've got 25, which is in that range there. I didn't answer the question properly because it wanted it as a probability. So it's going to be 21 out of 40. So I would have dropped a mark there because I didn't write it as a probability. So they've said anything between 19 out of 40 and 24. So we got 21, which is bang in the middle, so that's fine. And again, the cumulative frequency curve can be done with straight lines in between. Okay, we're going to now draw a cumulative frequency one, then we'll answer some other bits. So let's try and do these a little bit quicker so that the video doesn't take too long. So cumulative frequency, we're going to have 5. We'll add on the 10 to get 15. We'll add on the 20 to get 35. I'm going to add on another 20 to get 55. I'll add on a 15 to get 70, and I'll add on a 10 to get 80. That's great because it adds up to the 80 that we've got here. These values are going to get plotted with these values on this grid that we've got. So going to look at this, we're going to say that 250 is going to go with 5, 300 is going to go with 15, 350 goes with 35, 400 goes with 55, 450 goes with 70, and 500 goes with 80. And again, it starts at 200, so I do want to put that little point down there like this. I'm going to connect them together. I'm going to use my ruler. You could do curved. I just think rulers are easier. And there's our cumulative frequency curve. It then says 60% of this group of people have a weekly wage of £360 or less. Is Juan correct? So we're going to find out how many people have £360 or less by reading it from the graph. Well, if this is 350 and this is 400, there's 50 along here, so each 2 squares would be 10. So I'm going to say that's going to be 360. So I'm going to draw up from 360 until I meet the curve, and then I'm going to read across here. That looks like it's, if that's 35, 36, 37, I'd say that's 38. So according to our calculations, we can see that 38 have less. 38 have a wage less than 360. And we're just going to compare that to 60%. If we do 60% of our group, which is 60% of 80, this is a non-calculator one, so we'll say that 10% of 80 is 8, which means 60% is 6 times 8, and 6 times 8 is 48. And we've said that there's 38, so is he correct? He said that 60% of them have a work. Is it correct? We're going to say no, 38 is lower than 48. So actually it's lower than 60%, it's not 60%, it's even lower. We've got these values, we've got the graph drawn, and the correct decision is that, well, 48 was one of the comparisons, and I think for our comparisons, it's going to be a no, because, well, I don't quite like the way that they've done it here. I'd probably say what I've got. We could have read the cumulative frequency. Instead of from 48, we could do it our way. I'd say it's about 39 here. It's kind of a bit tricky from the way they've presented this, but guaranteed, what I've said here is definitely going to give us the marks. Okay, we're going to draw a cumulative frequency graph. They've already done the cumulative frequency, so it's these values, and then we're going to estimate the median. Okay, so I'll zoom in so we can see these at the same time. Okay, we have got 5 goes with 4, 10 goes with 11, 15 goes with 24, 20 goes with 34, like this. For some reason I have cut this number off, that should say 40. And then we've got 25 goes with 38, and 30 goes with 40. then it just becomes a case of joining them together. Like I said before, you'll always see me doing them with a straight line. And that's part A of the question, nice, easy, 2 marks. Part B just says, use the graph to find an estimate for the median height of the plants. So the median is going to be at 20 that we've got there. So I'm going to just read across from 20 and we'll see what the median height is. So we looked across like this and then down. I would say that the median height, if this is 10, that's 11, 12, 13. The median height is about 13.5. So that's 11, 12, 13, 14. Yeah, that's about 13.5 that we've got there. So I'm going to say that the median height is 13.5. They're going to accept a range of answers for this. So we've got the graph drawn and something between 13 and 14. Well, perfect. We got 13.5. Okay, we've got just one thing to see what's wrong with this cumulative frequency table. So it says there are 50 people solving the puzzle and we're going to try and spot what might have gone wrong here. Well, I probably would check these first. I've actually already spotted it, but we'll check these things. So that's going to be the 13 is the 5 plus 8. Great, that's 13. The 25 is the 13 plus the 12. The 40 I'm adding on the 15. That's correct. Then I'm adding on the 7 and I'm adding on the 3. I've spotted what's wrong. It's these values here. These values should not be written in that way. So the one thing that is wrong with the cumulative frequency table is that the inequalities are incorrect. They should all start with 0. They should all start with 0. Like these bits here, that one's a 0. Just like we've got on here, they all started with 0. Let's see which ones they would accept for this. One of them just should be corrected, or they should all start with 0. Okay, I think we've got this last question on this one, and then that's everything on cumulative frequency and box plots. And it's quite nice because it's a question that blends these two things together. So it says the times that 48 trains left a station on Monday were recorded. The cumulative frequency graph gives information about the number of minutes the trains were delayed. Correct the nearest minute. The shortest delay was 0 and the longest delay was 42. On the box plot, draw the information about the delays on Monday. Now I'm going to zoom in so that we can hopefully see these at the same time. What I'm going to do is actually just begin by saying that the shortest delay was 0 minutes. I'm going to put that onto our box plot that we've got. So I'm going to say that for Monday, we're just going to say that there's a 0. I don't mind doing it at the top of the grid, that's perfectly fine. And the top is 42. Now I'm going to find the other values that we've got. So I'll begin by doing the median. Now it looks like there are 48 trains, right? So the median is going to be halfway. You don't have to do any of that +1 kind of thing. So if I do 48 divided by 2, that is going to be the 24th for the median. So actually, if I put the 24th, that's where I'm going to try and find the median. 24 is going to be coming across here like this, and then coming straight down. So we've got that the median is 10. And you know what I'm going to do? I'm actually going to put that onto the box plot straight away like this, that the median is going to be 10. Now I'm going to do the upper quartile. Well, no, I'm probably going to do the lower quartile next. The lower quartile would be if I did 48 divided by 4, which would give me the 12th value. And the 12th value, when I read across on this graph, is going to be here. And that comes down straight away like this, which is going to be 4. And again, you can just see it's going to flow straight down into the diagram because of the fact that they've got the same axes. So that's going to be 4 for this part. And then the upper quartile, well, you can tell if the lower quartile is 12 and then 24, the upper quartile is just going to be 36. It's going to be the 36th value because you're dividing it by 4 and then timesing it by 3. So when I look at the 36th value for this, I'm going to go across at 36. And then I'm going to come and read down here and it gives me the value 20. Like I said before, it just kind of flows straight into this part of the diagram. So I'm going to put the 20 as this part and I'm going to connect the central box together and we're done. So again, I think my box is going to be perhaps a little bit wonky, but it would still give you the marks. Okay, it then says 48 trains left the station on Tuesday. The box plot gives the information about the delays on Tuesday. Compare the distribution on Monday with the distribution on Tuesday. So first of all, we can see that the median for Monday is higher than for Tuesday. So I'm going to write that down. The median delay time, so we put it in context. The median delay time on Monday was lower than Tuesday? No, was higher than Tuesday, because it's 10 versus 9. Higher than Tuesday, and that's because 10 is higher than 9. Now we're going to compare the ranges, or the interquartile range. Well, I'm probably just going to do the range because I think the range is so easy to do for this. I'm going to say that the range for Monday was larger than Tuesday. The range for Monday was larger than Tuesday. And again, you can see the range is 42 versus 33. So that's 42 being greater than 33. Of course, if you wanted to, you could do the interquartile range. I've got one of them in the context of time, which is what it's talking about. That's what it wants here. Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 and 30 minutes. Is Mary right? Well, no, we don't know if there's anything between 25 and 30. All we know is that there are some delays that were between, what's that going to be, 17 and 33. Is Mary right? No, not necessarily. Not necessarily. We only know that there are some between the upper quartile, which is 17, and the highest, which is 33. In fact, there's 12 between them. So we've got the correct values for this bit for the box plot, and we've got the correct comparisons of the medians, and it does want one of the things that is in context. The last part is no, with the statement explaining there might not be any delays between 25 and 30, as the 25% may be between 17 and 25, or 30 and 33. So not necessarily, we only know that there are some between 17 and 33. So I guess we should say, not necessarily, yeah, we've already said it, we don't want to over-explain it, okay? So that is everything on cumulative frequency and box plots. We're getting very near the end of this playlist, of this series of videos. So if this is helping you with your revision, please do me a favour, just drop the video a like, subscribe to the channel, make sure you're speaking to any of your friends who are doing their revision and telling them about it, because I would find that really useful. Thank you so much, good luck.